Good morning, good evening, good afternoon, everyone. Welcome in Salesforce FX Hour. Today we are going to talk about Salesforce data design and implementation. We have a great speaker, Brian, with us. So let me hand over him for his introduction and the presentation. Hand over to you, Brian.
Hey, Amit, thank you so much for having me. Always awesome to join you on Apex Hours. I appreciate the invitation. Like Amit mentioned, today I'll be talking about data model design and implementation, and we will be covering a few topics. Before I get into our agenda, just very quickly about me, I am 14x certified Salesforce architect. I've been doing Salesforce architecture for about 10 years. Overall, I've been doing about 18, now more than 18 years of building and designing CRM systems. You can find me online at the Shea Consulting website. You can find me on LinkedIn. You can find me on Twitter. This is actually incorrect. This Brian Shea, all one word, there's no space there. But definitely feel free to reach out to me on LinkedIn or Twitter, and don't hesitate to reach out, send a DM, post something. I'm actually going to be going through a solution design example, and one of the things that I have really enjoyed about giving this presentation is a few folks DM'd me some other possible solutions. So definitely, if you watch this and you see the example that I put up, would love to hear your other possible solutions. So don't hesitate to DM me on that. All right. And in terms of our agenda, we're going to be talking about data model design and implementation within Salesforce. So I'm going to give a quick introduction. I'm going to talk about conceptual or logical data modeling and what that is and how it's different from sort of the Salesforce object model. I'll talk about how to translate a conceptual model into Salesforce. That's going to be the main focus. Agenda items 2 and 3 are going to be our main focus today. And then we're also going to hit on a few other considerations for building your data model in Salesforce. We're going to talk about some enterprise considerations and considering the entire enterprise landscape when we're developing our Salesforce data model. And I am going to run through some of the relevant well-architected principles for data model optimization and handling large data volumes. And I will talk briefly about data model governance. So in terms of data model, folks on this call won't be surprised to know we've got practitioners on this call. Your data model, your object model is a foundational piece of your Salesforce org. If you get your data model right, you get your object model right, you're going to have a much easier time scaling your system. You're going to have a much easier time building simple, effective automations, a good UI, a simple security model, all the things we want in a well-architected system. What I like to say is poor data models cause unnecessary complexity everywhere in the UI, in automation, in the security model, in reporting. They manifest, it's a root cause that manifests itself all over the org. And last point to call out, I know this Apex Hours audience is a mix of admins, developers, architects, all kinds of different Salesforce practitioners, consultants. And one point I want to call out here is data model design and Fluency is not just for Salesforce architects. I recently saw a conversation, I think it was on LinkedIn, that Jody Herbeck, who's a thought leader in admin and BA and Salesforce fundamentals and concepts, she put up a thread about data models, and a discussion sort of came up about, are data models just for architects, or are they for, admins, developers, etc.? Do admins, developers need to be fluent in data modeling? And Jody said, yes, it's a concept for everybody, not just architects, and I completely agree with her. I think it's something that while an architect may be the one who's designing a data model, particularly for a large project, there's a ton of value in sort of all Salesforce practitioners having comfort and fluency in what a well-designed data model looks like. Okay, so conceptual and logical data models. So I am going to, for our purposes in this presentation, I'm going to define some terms here. So I've used the term conceptual data model. There's also a term logical data model. There's a concept of an entity relationship diagram. For our purposes today, I am going to consider those three terms all synonymous. There are differences and different people use those terms in different ways, but for our purposes, I'm going to use them synonymously, and I will be using the term conceptual data model because that's the term that I kind of grew up with. But our purposes, our definition of those terms for today's purposes is that it's a high-level view of entities and relationships. It's a normalized view. And I won't go into the details of what normalized means, but when I use normalized, I mean third normal form, which is a kind of a particular set of criteria for judging something to be normalized. And it is system agnostic. Okay, so it's not a Salesforce specific data model or an ERP specific data model or an Oracle data model. It's a set of entities and relationships that exist in business data, regardless of what system it is implemented in. And an important point I want to call out is our conceptual data model is different from our Salesforce object model. They're not the same. And I'm going to illustrate in this presentation how they're different and why going through and creating a conceptual data model can add a lot of value for your project. So I had mentioned earlier this concept of third normal form. I'm not going to get into that in terms of data modeling and conceptual data modeling, but when people sort of in the industry talk about a database and being normalized, they're generally referring to third normal form. It's kind of a standard for enforcing uniqueness, reducing redundancy in kind of a practical way. And the point I want to call out here is the Salesforce object model is denormalized compared to a third normal form data model. That's by design. That's not an accident. And the reason why is because denormalizing data at times can help improve performance, and in the Salesforce case, sometimes improve kind of a user experience situation. And what we like to say is we denormalize for performance, we normalize for uniqueness and to reduce redundancy. So somebody who's designing a data model wants to be aware of when to denormalize for performance and when to normalize for uniqueness. And an example of this in terms of practical example of when Salesforce may denormalize is if we look at kind of a classic conceptual data model or entity relationship diagram. Salesforce may translate what we would consider an entity in an entity relationship diagram into a pick list or a field. And again, this can greatly improve performance and usability, denormalizing in that way. And again, as we get through this example, we'll kind of see some examples of how this denormalization and normalization happen. And again, one more thing I just want to call out. There are times you sort of hear on projects or out there in the world, people will sort of use denormalize as a sort of a negative term. They'll say, oh, this data is denormalized, and meaning that it's hasn't been organized or designed properly. Sometimes that may be the case, but oftentimes denormalizing is a conscious choice, and it's done to improve performance. So I want to call that out. Amit, before I go on, any questions so far? I know I've gone through a lot.
No, you're good to go.
Okay, thanks. Okay, so as I mentioned, there's a difference between a conceptual data model and a Salesforce object model. I would argue for larger projects, it can be worth creating a conceptual data model. I know there are times when it can feel like you're doing this extra analysis step that may feel, particularly if you're very fluent in Salesforce, it may feel like this extra unnecessary step. But I would argue on bigger projects that a conceptual data model design can provide a much more clear understanding of how business data is represented. It can give a much clearer sense of requirements and entities, relationships, cardinalities, possible redundancies, and a lot of value in going through and doing the exercise of creating a conceptual data model rather than just jumping into creating your object model. And for this presentation, what I'd like to do is kind of look at an example, a hypothetical example of a business request. And what I'd like to do is kind of walk through the request and then what a conceptual model potentially could look like for this request to satisfy this request, and then go through what a Salesforce solution could look like. So we'll kind of see what the conceptual model, data model looks like, and we'll look at what a potential Salesforce solution design could look like. And hopefully that'll illustrate the differences between the two and the value of doing a conceptual data model. I'll say also for this example, just for time purposes, this is a very small example. Obviously, for a project, you may be doing something much larger. And as I mentioned before, for larger projects, larger initiatives, that's when doing a conceptual model really can add a lot of value. So this is a little bit shortened for time, for our context, but hopefully this illustrates the value of conceptual models. So as a Salesforce professional, we may receive a request that looks something like this. In the first one we've got here, it's a user story. As a sales user at XYZ Corporation, I want to specify a business unit associated with an opportunity so I can filter or sort my opportunities by business unit. So that's kind of a user story request, or you get something that's even more sort of explicit, solution explicit, let's say. Could you create a field on the opportunity to track business unit? So both of these things are sort of leaning towards the idea that we've got an opportunity, we've got a business unit, and we want to be able to categorize our opportunities by business unit. And so you could see a quick solution to this as somebody just adds a custom pick list field to opportunity. Very quick. You know, you could see a support ticket coming in, or a user story coming in, or an enhancement request coming in, and somebody quickly cranking that out and just adding a quick pick list to that. But if we dig into, as we should, if we dig into the request, if we dig into the user story and we ask some questions about it, some additional, in our example, some additional requirements came to the fore after discussing with our business stakeholders. So I'll go through those now. XYZ Corporation currently has 4 lines of business, 4 LOBs. The last time an LOB was added was 3 years ago during an acquisition. And XYZ Corp currently has no plans to add more lines of business. So we've got 4 lines of business, and this statement kind of implies that this is something that's relatively stable. It's not something, they've got 4 now. It's unlikely they're going to have like 40 next year, right? Maybe they'll add 1, maybe they'll remove 1, but seems from this, it's relatively stable. Sales users may be assigned opportunities for 1 or more lines of business. So sales users can traverse multiple lines of business. They're not assigned to just 1. Each opportunity is associated with exactly 1 line of business. Each line of business has a distinct set of products. An LOB can have 0 to many products. Each product has exactly one line of business. Each line of business has a distinct set of sales stages. And the last point here is XYZ Corporation uses Sales Cloud. So with that information, we can take those requirements, and I don't even want to call them requirements. We can take that information about the business and we can model the entities and the relationships that we saw in here. So if I just run through this, when we looked through our information on the previous slide, we have lines of business, we have sales process that was mentioned, we've got opportunities, we've got products, and we have opportunity products, and we have sales users. So this is a conceptual data model. Again, some of the things to call out here about it, it's very high level. There's no fields, there's not a lot of detail. We're just high level entities. What are our main business entities? And we're expressing the relationships between those entities. We're expressing what's called the cardinality, right? So how many, to use an example of cardinality, I mentioned on the previous slide that a line of business can have many opportunities. Each opportunity will have exactly one line of business. So we're expressing cardinality in what's referred to in this diagram as crow's foot notation. So this side represents, we've got many, upward bound of many, a lower bound of 0. And this / means exactly 1. So we have a line of business can have many to 0 opportunities, but an opportunity has exactly 1 line of business. And to just go through the rest of this example, a line of business has exactly 1 sales process. And in this example, the sales process has 1 line of business. An opportunity has many opportunity products. Product has many opportunity products. This in Salesforce terminology is sometimes called a junction object. And a line of business has many or as few as 0 products, and a product has exactly 1 line of business. And as we mentioned before, a sales user can be assigned many opportunities. An opportunity has exactly 1 sales user in our example. One other point to call out here, it's not represented here with a relationship, but a sales user can be associated with can traverse many lines of business. So they're not just associated with 1. So that's our conceptual data model. And as you can see, we took like 2 pages of information about the business and its data and the relationships, and we're able to represent it relatively concisely in this diagram that has six boxes on it, right? So this can be a really powerful way to articulate what are our main entities, what's the relationships between them, and we can do it in a way that we could review this with our business stakeholders. I wouldn't just send this to business stakeholders and ask them to review it themselves, but you could review it with business stakeholders and you could walk them through the entities and what you heard as being the cardinality between them, and you could get their feedback on it. You could get them to sign off on it to really nail down what the business landscape is for this data. Okay, so can be a really powerful tool for articulating our business data. So that was a conceptual model. In terms of our Salesforce solution design, this is one possible design for implementing the requirements. And there are many others that you could potentially come up with. But what I want to do is walk through this one possible design And I want to call out the ways that this Salesforce solution design kind of differs from the conceptual data model to show you the difference and show you where the conceptual model can add value. So in here, we have our opportunity object, we have our product object, and I put here a line of business, and you can see I've kind of graded out and I put dotted lines around it. This is because this is not an object that in this solution we're storing in Salesforce. It's not an object. It's not a custom metadata type. I just put it here to represent the fact that there is a business concept of line of business that is important to this solution, even though we're not storing it as an object. And that concept of line of business is expressed in Salesforce on the opportunity as an opportunity record type. So in this example, let's say we had 4 record types, one for each of the corresponding 4 lines of business. And we have a standard Salesforce field called product family. And we could capture our line of business, our 4 lines of business in the product family pick list, okay? So what we've done here is we've taken this concept of line of business and we've captured it on the opportunity in a standard field in the record type, and we've captured it on the product. Okay, so relatively small sort of enhancements to the Salesforce data model. Additional items that we would want to build to enforce kind of referential integrity between our line of business and our opportunity and our product. The first one I mentioned, we've got opportunity record type and product family that corresponds to our line of business. The second item we have here is a validation rule on opportunity product that ensures that only products within the line of business are added to opportunities for that line of business. So as we mentioned, as we saw in our previous list, an opportunity should only have products associated with the same line of business. So we could have a validation rule on opportunity product that supports that. From a UI perspective, we would most likely want to streamline, filter the list of products that a user could select for a given opportunity. And that could be achieved with a custom Apex controller and Lightning Web Component to only display the products associated with the corresponding line of business. And another kind of user experience thing, the fact that we've got opportunity record type expressing our line of business, that could be used to drive the sales process, the stages, and the path on the opportunity. So what I want to call out here is we went from this, which is an entity relationship diagram, to a solution design in Salesforce, and they're very different, right? We only have two fields that we're capturing. We're not capturing line of business as a standalone entity, as we do here, okay? And we're using validation rules, we're using some code in places, we're using some out-of-the-box features like record type and sales process, stages, path, to bring this solution together. So it's really important to call this out because, as you can see, this here, we're getting into a lot of technical detail, which we need to for our solution, but it doesn't really express our sort of pure business requirements, pure business data relationships, as well as this conceptual data model does. So again, for bigger projects, this can be a really good communication tool with your business stakeholders. And it can really help you to, as you're thinking through possible solution designs, think about your requirements, think about the ways to address them, and think about the potential trade-offs. As I mentioned, I've done this before, and there are other ways to implement this data model. in Salesforce, and having a good conceptual data model can be a good way to look at various implementation options or solution design options and look at kind of the trade-offs. So a few points to call out here. Repeating a few points. Number one, a common misconception is that the Salesforce object model is the same or similar to a conceptual data model. Obviously, from our previous example, we've seen where they can be quite different. And as I mentioned as well, in the Salesforce model, there can be conceptual entities or fields like our line of business that aren't even implemented as an object. They could be sort of implied in the object model and then enforced with some other feature within Salesforce, whether it be automation or validation, etc. A few points to call out here. Well-architected design will implement entities, fields using the Salesforce object model when possible. So I want to be clear here, all things being equal, we'd rather implement our conceptual entities as Salesforce objects. It's not a best practice to be enforcing entities, fields, referential integrity using automation tools. That's not best practice, and I don't want to imply that it is. However, there may be scenarios where denormalizing for performance and for user experience outweighs the drawbacks. And you could argue in this example, again, different ways to implement it. You could argue that there's better ways to implement it than this. But it's often, as with this example, a set of trade-offs that the architect or the team would need to assess and would need to assess how well it addresses the requirements and then the costs of implementing and the cost of maintaining the solutions. So there's kind of a, with any solution design and looking at potential solutions, there's many different trade-offs to consider and costs and risks to consider. And this example also illustrates how a simple enhancement request can actually hide something that's much, much more complex. And I think this gets back to the point that I mentioned earlier in the meeting, of the value of having all our Salesforce professionals being fluent in data modeling and not just have it be something where it's an architect needs to go through it. So in our user story that we started out with, this would be something that an admin could get in their queue of user stories or support requests. And an admin that is sort of fluent and comfortable with data modeling may look at that and may see the potential impacts of sort of oversimplifying this. So this kind of data model fluency can be really valuable to have across your Salesforce team and not just be a skill set of architects. And as I mentioned before, conceptual data model gives us a clear picture of our requirements in our data model. And if possible, it can be helpful to have the conceptual model review it with business stakeholders and get their sign off. I will say different business audiences may be more or less comfortable with reviewing conceptual data models. I've worked with some that are very comfortable with it. They're comfortable with talking through entities and cardinality and all that. And I've worked with other business stakeholder groups that are less comfortable with it and feel like it's sort of too technical or too abstract or conceptual. Where possible and where reasonable, it's great to review it with them, and it's great to get their sign off if possible. And as I mentioned before, a conceptual data model gives us a great starting point to consider options and trade-offs. So as I mentioned before, when I've done this talk elsewhere, it's great to get some folks think about this on their own and identify possible designs, alternative designs. So as an exercise, feel free to kind of think this through yourself and think through some possible solution designs to address our conceptual data model and our requirements. Consider the pros and cons of each of your solutions or your solution options. And you want to think about not just how those solutions address the business requirements, but the implementation costs, the upfront implementation costs of those solutions, and the maintenance cost. And also we want to think through, sort of overlaid with that is think through our well-architected principles and how our design matches up with our well-architected principles. Also worth thinking about for the design that I provided earlier, what are some of the drawbacks of that potential design? And as I mentioned earlier, with an actual implementation, you'd want to be researching additional opportunities and out-of-the-box features in Sales Cloud, other relevant clouds or managed packages. We're talking about products, so there may be worthwhile looking at CPQ to determine where standard features rather than customization can be used. One of our well-architected principles is to use out-of-the-box data models when possible, and that's something that doing some research and seeing when we can use standard data models or kind of out-of-the-box functionality can be really powerful for building a more maintainable and potentially solution that's a lower implementation cost. So that's most of our talk today, is talking about conceptual data modeling and then how we translate it into Salesforce. But there's a few other considerations that I want to walk through today that impact your Salesforce data model. There's not enough time to go through these in really any level of depth, but I want to call them out so you're familiar with them. One other thing I want to call out is there is an article that was written, I think almost 10 years ago, on the Salesforce developers site by Greg Cook that goes through many of the principles in terms of data modeling, logical data modeling, translating it to Salesforce, in some of the concepts I'm going to talk about. In Greg's article, it goes into detail, really fantastic article. I recommend, if you're interested in this topic, to check it out. It hits on this presentation, and Greg's article hit on a lot of the same concepts. So in terms of enterprise landscape, obviously in the modern enterprise, Salesforce is one of many important applications. Okay, so when we're building our Salesforce object model, we want to be aware of other systems that may be storing similar information. So one concept to call out here is enterprise data modeling. It's the idea of having a data model that is cross enterprise. So it's not just sort of in the CRM space, but it's across the enterprise. And again, the value of having our entities and our relationships expressed conceptually as opposed to just within a particular system or particular system implementation can be really powerful. And master data management is this concept of thinking about which system should be the source of truth for each entity or field, and the processes for keeping various systems synchronized and reducing redundancy between systems to make sure we've got accurate sources of truth. So enterprise data modeling and MDM are really important when we're thinking about, particularly in a larger enterprise, Salesforce and what data should be in Salesforce and what data shouldn't be in Salesforce, and where Salesforce should be the source of truth and where Salesforce should be consuming data from other systems. Okay, so there's a lot there's kind of a lot to potentially go into here, not just the enterprise data modeling and MDM, but thinking about and having awareness of different integration patterns, whether it be, a virtualization pattern, a data synchronization pattern, a replication data pattern, for folks that are interested in that topic. Salesforce Developers has a great resource that goes through various Salesforce integration patterns in the specific technologies that can be used to implement those patterns. But our purpose is here, talking about enterprise landscape, is really to understand that Salesforce is part of a larger system ecosystem, okay, and making sure that Salesforce is housing the correct data and other systems are housing the data that's correct for them, and making sure we don't have redundancy across systems. So that's enterprise landscape. And then Salesforce Well Architected has a number of principles that are relevant to data modeling. I talked through some of them in passing, but I will quickly scan through some of them here. There's a couple of pillars within Well Architected that are particularly relevant. So we've got within trusted and scalable, there's a concept of data model optimization. And then also there's a concept of data volume management. So there's some patterns and anti-patterns that you can check out under these two. I have them over the next 3 slides. I'm not going to go into them in detail, but I'll pull out a couple of examples for each. So under data model optimization, that we've got our well-architected best practice, or a well-architected pattern, is to use standard objects where possible, and at the same time have tables denormalized for scale and for performance. Okay. And then in data volume management, we've got some best practices around how many records should be parented under one parent record. So best practice, no more than 10,000 child records should be underneath one parent, and no user should be assigned more than 10,000 records on the same object type. And obviously there's more here that you can read through. We've got links here for our data model optimization and data volume management in Well Architected. And the last concept I want to go through for this session is, we've talked about how to design and implement our data model within Salesforce. Really important to make sure that that data model is governed in a way where it continues to perform at a high level and not collect kind of technical debt over time as additional enhancements are made, and users are entering and managing data within our data model. So some artifacts and some processes that can be valuable here. One is a data dictionary, which is business definitions of our entities and fields. Okay, this is one of those tools that is can be a lot of value. At the same time, within a lot of some organizations I've seen have had a tough time with data dictionaries because they haven't exactly gotten the balance right of how much information is the right amount of information. So you see some organizations that have no data dictionary, and then you see other organizations that really tried to build a very, very, very thorough data dictionary and almost went too far in that direction. I'd say with a data dictionary, you want business definitions, and the purpose of these business definitions is a few things. Number one, to understand from a business perspective what that field is storing or what that entity is storing, to give clarity to our users in terms of what they should be inputting into a particular field. And also, as new feature requests are made, having a place that we can go to see if that field that's being requested already exists. So when somebody requests a new field, one of the things that can be a part of that request is a definition of what that field is from a business perspective. And then the person who's looking at that enhancement request can take that business definition and look in the data dictionary and see if something already exists. And then as they're working with the business stakeholder, figure out, is this something new? Is it something different? So we're not having 3 or 4 or 5 or 6 different versions of the same data in 6 different fields that have been implemented over time. I mentioned too, in terms of data dictionary, that there's different models with a data dictionary. In sort of an ideal world, this is not just a sort of something that IT maintains and has, it's something that the business has access to and can see. So when somebody's ideally creating a business user's creating a support request or enhancement request, hopefully the first thing that they're doing is looking at the data dictionary and seeing if something like that already exists. And there should be knowledge and governance across the organization, so somebody's familiar with the data that already exists. But that's a data dictionary, and that's the role of data dictionary. Data ownership. So who is the owner of a particular entity field? Who is responsible for maintaining the data? This is really important. If we're creating a field that somebody wants to consume the data from, it's really important to know who's going to be the owner of that field and who's going to input data into that field, and what the process is for inputting the data. So it's not just about putting a field in, but it's about knowing the roles and responsibilities in the process for having that data populated and consumed. And data governance process. I kind of alluded to this earlier, but what is your organization's process for getting new objects and fields approved and implemented in the system? Really important to have this, again, to avoid the situation where we've got the same field that's been built 5 different ways in Salesforce over the years because there was no process to govern how to assess new fields and new object model changes, and those requests were just implemented by someone and didn't go through a governance process. And the last point I want to call out here is data lifecycle. What is your organization's criteria and process for archiving data? So it's not just about creation of data, but what is the end of life of data, and how do we archive it for security and performance reasons? All right, so real quick, we've got a couple of minutes left, but some additional resources for folks to check out on a number of different topics. I had mentioned earlier Greg Cook's awesome article. Like I said, I think it was from about 10 years ago. It's an oldie but a goodie, really great article. If you're interested in any of these topics, check that out. The Salesforce Data Architect certification is great if you're interested in kind of the data architecture side of Salesforce. I have a site that goes through data normalization in a lot of detail. It goes through the, what is first normal form, second normal form, third normal form, fourth normal form, fifth normal form. There's all these different levels, cardinality, all these different things. If you're interested in that as a concept, you can check out this resource. Agile Data is a site maintained by a professional by the name of, I believe, Scott Ambler, who's done a lot in the space of not just data modeling, but how to do it in a agile-like way, as opposed to sort of an upfront waterfall-like way. Great resources here. A couple of sites that talk about master data management, and the Salesforce Developers Integration Guide that I mentioned before, and we're missing a bullet here, but Salesforce Well Architected is a resource that you should check out as well. So all great things. a lot of topics here, like as folks on this call know, like master data management is something I spent maybe a minute on. That's its own topic. There are professionals that just do master data management, or database normalization. There's professionals that just do that. So if there are particular areas that you're really interested, you can go really deep into those. So wrapping up, we got a couple minutes left. Amit, any questions that you want to go through?
Not exactly. You cover most of them in your presentation itself. Thank you so much, Brian.
Yeah, thanks so much for having me. And like I mentioned, if folks want to connect with me on LinkedIn or Twitter, definitely go ahead and do that. If folks go through the exercise and have solution designs that they would like to send along, definitely feel free to post those to LinkedIn or Twitter, or send those in DM. Always great to see those and see the various different ways that people solution our requirements. So thanks so much for having me on it.
Thank you so much, Brian.